Operating the machine is straightforward. After having connected the unit, we can close the input isolator and the output circuit breakers. This configuration may vary depending on your particular model. Turning the unit on is straightforward. We simply switch the control switch to the on position and we adjust the dial to correspond to the capacity of the incoming power supply. The unit will switch on and you'll have the blue light to give you an indication of status. With mains power connected, after a few seconds the unit should switch over, the mains on light will be displayed and the unit will indicate that it's in a charging mode. We also have an emergency stop button which can be used to turn the machine off. On this model, the emergency stop is provided by a key operated switch. As soon as the switch is reset, the unit will come back to its operating mode. In addition, we have the battery monitoring device. The monitoring device here gives us information on the state of charge of the battery. We can display a number of pieces of information on the standard mode. SOC indicates a state of charge as a percentage. 100% is full, 50% is half discharged. By selecting either the up or down or the plus or minus buttons, we can scroll through other information that is displayed. TTG indicates time to go. At the moment the unit is not being used, so the time to go is infinity. As the unit is loaded up, this display will report the number of hours that the unit can operate until it reaches its set discharge level. We also can interrogate the battery voltage. This battery is fully charged and is sitting at 51.5 volts. We can also see how many amps the unit is delivering or is being taken from the battery. A negative figure is a discharge and a positive figure is a charge. And finally we have consumed energy in ampere hours. The unit has a 0 rating for fully charged, and as you discharge the battery it will count down, -1, -2, -3 and so on. And we scroll back to the beginning of the information. It is possible, using the advanced functions, to further access the device in order to make changes to settings and also to interrogate historical data such as the number of charge cycles, the most deep discharge, the most shallow discharge and the most frequent depth of discharge, or the average depth of discharge, as well as the last full charge that was achieved. With the unit in the on position, we can see that there is a small discharge, which is the power required to operate the machine. And in a second the unit will switch over into the charging mode and we will see the charge current increase. And again, this machine is already more or less fully charged, so the charge current that's being drawn is actually quite minimal. If we connect the AC power input with the input isolator already switched on, input power is connected to the machine and we can turn it on. The current adjustment is already set to 63 amps and the unit comes on in inverter mode. During this period at the moment the unit is synchronizing with the incoming supply, and in a second or two it will switch over. The unit now starts to charge the battery. We can see the input current, or rather the charging current, is increasing, and also the battery voltage has risen. So we are now charging the battery and you can hear the fan running, which is normal. If we now connect to load, we have a heater load connected on this socket, and we close the output circuit breaker. We now have load connected to the machine. At the moment, the heater loads are directly connected to the input, so the input power is connected to the output and is running our loads, and the unit is simultaneously charging the battery. If we now disconnect the AC input, the unit has automatically and instantly reverted to working as an inverter. There was no break in the power supply and the load is still running. But we now have a discharge on the battery. Now the battery in this unit is intentionally low because we want to simulate the low battery condition. The auto start cable is connected to the output, and in this case we have a simulator which will just give us a visual and an audible alarm at the point at which the auto start function is activated. The auto start trigger is set to operate under two different conditions on this particular machine. One is for battery voltage. It's set at 44 volts, so once we reach 44 volts for a period of a minute, the auto start function will be activated. But that activation could also be on a state of charge, so we can set a trigger level of, for example, 50% discharged or 60% discharged as a point at which the auto start is triggered. We could also, and in addition, we can have a load level trigger. For example, if the load has been greater than 6 kilowatts for more than 3 minutes, that may also be a trigger to start the generator. So as the discharge voltage or the battery voltage is now approaching the set level, we've gone over the 44 volt level on the battery, so the timer will have started, counting 60 seconds before we get activation of the auto start function. So there we have the auto start alarm. The generator would now start, simulating input power. We'll connect the mains, and in a second the unit will transfer over. And there we go. And the loads are now connected directly to the incoming power supply. Here the fans have stopped on the inverter, and the unit is now recharging the battery. So the negative value of current has returned to a positive as energy is now being put back into the battery. So that is the basic functionality of the machine, and at the end, if we want to turn the machine off, we just turn the control switch to the off position, all output power is killed, and if I want to, I can just turn off the input isolator and the output circuit breakers. Disconnect the charge lead, remove the connectors, and that's it.